Greetings, salutations, and welcome to the Daily Space Weather. Coming at you from the Smash News Network, Least Busted Name and News with our fresh spring colors. Let us know if you like the new Smash News Network logo colors there. We got the ultra bright spring pastel colors coming at you, and some imagery here from the GOES R. So this is the past 24 hours in 94 plus 131 angstroms, and we've got some sunspot growth and increase in the radial flux, and the Earth is continuing to be buffeted by a coronal hole high-speed stream. We'll tell you all about it. And we've got some sunspots that are turning into better candidates for large solar flares. So that's one of those sunspot groups in the north. Here's a large sunspot group in the south. We've seen some umbral migration in the past 24 hours. You might be able to see it in this close-up imagery of that same 24-hour span of time. Again, this is from the GOES R today. And then here is your southeastern limb. I think we'll get at least one new named sunspot group today, maybe two named sunspot groups. We'll see what happens and keep you posted. So let's do another zoom in here and then take a look at sunspots from a holistic perspective, at least from Earth's perspective. So once again, we do have some umbral migration down here, a little bit of growth happening up here and over here in the northwest. One new sunspot group rose since yesterday also. That one should get a name soon. Here's your SDO magnetogram. These images are yesterday plus today. The first images we opened the video up with were 24-hour videos from when we streamed. If you want to support the channel, consider becoming a member of the Smash Team at smashomash.com/Smash Team. It's the official subscription services site of the Smash News Network, Least Busted Name and News. Join at the silver or gold level to gain additional content. We do put up things like ringtones and, minor stuff like explanation of the solar cycles. No big deal. That's for the gold Smash Team members. So support the channel that way. Thanks to everybody who has, especially gold and silver Smash Team members. There's also a bronze membership. Links to the forum, links to the Hemp Lucid shop, and more on the homepage as well at smashomash.com. So welcome to the Neo Renaissance. Congratulations on realizing the channel exists. We're frankly surprised that you have. Not because the content sucks, because there are issues with the quote platforms, end quote. Anyway, if you visit the links below the video, you may find the link to the Redbubble shop, where products are listed in order of best selling. Today's featured product is Forgive, Remember, and Hold Accountable, because holding a grudge is like ingesting poison and expecting the other person to die. So give out some good wise advice, like a sage, or perhaps a guru, by wearing our Forgive, Remember, and Hold Accountable products, or maybe even a mouse pad, who knows? If you've got to be reminded every time you look at your mouse pad to forgive, remember, and hold accountable, because forgiving and forgetting is so 2019, right? Also, links to the Hemp Lucid shop once again below the video. Enter the promo code SMASHOMASH to save some dough on your checkout at Hemp Lucid. That's our paid endorsement, and let's get back to what's going on here on Croissant Earth. So we're interested in what volcanoes are erupting, so let's do a rundown. Suminosejima is producing a 7,000-foot plume of volcanic ash, flight level 070 over the Suminosejima volcano in the Ryukyu Islands. Mount Ibu also exploding, flight level 060, 6,000-foot ash plume. 14,000-foot ash plume from Semeru on East Java, Indonesia, as it explodes. It's producing a flight level 140, flight level 230 over Popocatépetl in central Mexico, flight level 150 over Fuego in Guatemala, flight level 210 over Nevado de Ruiz. All three of those volcanoes are exploding. Saab and Kaya were unable to detect whether or not it's going off. Please do not attempt to pole vault the caldera. If you're going on a volcanic vacation, leave your vault pole at home. Next, global seismicity. And we're a little bit overdue for a 7 magnitude earthquake. We're seeing some information in the ionosphere that could perhaps add predictive value, but frankly, it's not really a concern of the channel at the moment. Although we do show the data, so if you are able to forecast earthquakes by looking at the ionosphere, you ought to be watching the channel as we show the data every day. It seems pretty convenient, don't you think? So let's see what's been shaken over the past 24 hours. The oldest 5+ magnitude quake that we've seen here was a 5.6 at Tonga. That one also at nearly 300 kilometers depth. Came in at 13:01 Universal Time yesterday on March 24th. So not only a low number of quakes, but very low magnitude quakes in the past 24 hours. No large quakes at all. The largest was that 5.6. There was also a 5.0 just west of it there, in between Tonga and Australia, near Vanuatu. That 5.0 was at 9:58 Universal Time this morning, and can we get back to space? Okay. And we are indeed back to space. So this is 171 and 131 angstroms from the GOES-R. And I'm pretty impressed by the imagery, frankly. It does have a little wider field of view than the SDO, which will be evident in this. This is the 195 angstroms wavelength. Again, this is the past 24 hours, and I don't know why the Earth scale is off the screen here. that was not the intention. Sometimes the Earth scale acts a little goofy when we compile these videos, and it's a lot of work compiling the videos, so often we don't worry about it. Anyway, there's your northern hemisphere. Again, likelihood of solar flares kind of high as it's been. There's your southern hemisphere. And we have had some great CMEs, coronal mass ejections, in the past 24 hours as well. So plenty of stuff to talk about here despite a slight decline in the Earth system in terms of space weather. There are lots of sunspots on the Earth-facing portion of the solar disk. 10.7 centimeter radial flux has dropped down to, or it's gone up. Yeah, it's gone up to 158 solar flux units. There is the 1-year graph. To put it in context, that black line on which my pointer rests will be updated in a few hours to reflect 158 solar flux units. Solar flux units are 10,000 joules of radial flux density, and they are the most proportional data set to sunspot number that we have. In fact, if you look at the cycles, if you've never seen it before, check out how proportional the radial flux and the sunspot number are. So there's a sunspot number in the upper graph, and there's a radial flux in the lower graph. You can see part of solar cycle 24 and solar cycle 25. Current conditions are geomagnetic unrest, although that's going to calm down and drop off to a KP, maybe even a KP2 here very promptly. So we'll tell you why in a moment. First, the NOAA forecast, forecasting an additional geomagnetic unrest to geomagnetic storm conditions through midday tomorrow. So tomorrow, Sunday, March 26th, we may see some additional stuff going on due to, quote, lingering CME and coronal hole high-speed stream influence. So it's a little bit vague. We'll let them slide with that. Here's the past 4 hours of Earth's magnetic moment from space. That was NOAA's forecast. Here's the past 4 hours of magnetohydrodynamic pressure, modeled by the Space Weather Modeling Framework. You do see some variations to the solar wind happening there. Some significant variations happening. And here's Earth's magnetic moment from the ground. Again, since we've got geomagnetic unrest conditions, we decided we'd show the North American ground magnetic perturbations. Please pay attention to the time and date stamps up there. That's the past 4 hours of North America's magnetic moment from the ground. This imagery does depict nanotesla magnetic flux density at the ground level, showing you likely places for aurorae, pipeline, railway, and power grid induction. Here's the full globe view, represented, of course, by a flat rectangle, which is surrounded by a rectangular pizza crust, or an ice cap resembling a pizza crust, which is Antarctica. Yes. Earth. It's a rectangular flat plane or something. Or it's croissant-shaped. Anyway, there are the past 4 hours on a global basis. And it just refreshed, so why don't we let it play all the way through? Just kidding, folks. I wasn't asking. I was telling. We're going to let it play all the way through. And now it's time to move on to the planetary K index. Engage. So there you can see this KP 7.67 moment, where the aurora could be visible as far south as Phoenix, Arizona. I'm not aware of any place farther south than that it was viewed, but we did show some great imagery on yesterday's Daily Space Weather video of red auroras over some giant saguaro cactuses. Saguaro? What are they called? Anyway, I'm not a botanist, although maybe one day I will get higher skills. Current conditions are still geomagnetic unrest here, KP 3.67. And we are expecting this to drop off, and we'll show you why here by looking at the data located at Lagrange 1 from the ACE and Discover. So we've seen the top pane here. You see that red line? That's the BZ. That's the vertical component of the magnetic field. And we see that getting into positive territory here. So when you see a strong negative BZ signal, you see a lot of induced current in the Earth system. And when you see a positive signal, you see more of a bouncing off of the Earth system. And we are getting around a zero line here. So it's fairly equivalent from the north and south poles there. You've got the vertical component is right on the center line. So you've got an equal amount of pull for that 7 nanoteslas in that top pane. So the top pane is the BT is the total field, and the BZ is 0. So you've got like 3.5 nanoteslas coming from the north and 3.5 nanoteslas coming from the south, so to speak. Current solar wind conditions are about 12 protons per cubic centimeter. Solar wind, did I say solar wind speed? Solar wind density is 12 protons per cubic centimeter. Solar wind speed about 525 kilometers per second. And it looks to me like we're having two coronal hole high-speed stream wind regimes here showing up at the same time. So these variations that we're seeing both in the plasma temperature, well, really all three, the plasma temperature and the speed and density, looks like two coronal hole high-speed streams. So it looks like they're sort of overlapping each other, and that can have a cancellation effect or it can have an amplification effect. In this case, it looks like it's more of a cancellation effect, as there are indeed two coronal holes that are likely to be influencing things. I just think one is more of a glancing blow coronal hole impact, and the other is a more slightly direct coronal hole impact. We're not expecting anything major from that. In fact, it's looking pretty weak. I suspect that NOAA's forecast for the coming couple of days here might be a little bit overdone. So we may see a little bit more geomagnetically calm conditions than in the forecast. And good morning, Tin Man 1057. Thanks for leaving a comment. Here's your GOES magnetometer. That's a GOES 16 and GOES 18 magnetometers over the past 24 hours, and they're in a tighter range here. Higher lows and lower highs. Let's move to the heliosphere. So here's the heliospheric current sheet. And if you're new to the channel, you may not be aware that the plasma coming from the sun is polar. This red plasma shown here is South Pole, and this green plasma over here is North Pole. Earth is just sort of in the front 1/3 of a South Pole-oriented current sheet. No sudden changes really expected there. Here's your line of sight field plot. Now, instead of looking at the top view, we're looking at the line of sight view. Solar polar fields depicted in red and green, and solar B field depicted in blue. The B field is in some ways the net field of the two solar polar fields, or you could say it's the field that goes through the magnet, however you prefer to interpret that. And here is our line of sight coronal hole plot. And we've got a bunch of South Pole oriented coronal holes here. So strong South Pole oriented fields. Let's take a look at that from SDO. So this is actually a 48-hour video. This is the past 2 days, if you're not familiar with what 48 hours is. And the reason I say we have two coronal holes is because there really are two systems here. So, and these are all south, by the way. That's south. This is south. These are south. And by the way, the sun's not actually shaking like that. That's missing data from the SDO. And let's talk about the Carrington rotation here for a quick moment. You know, when we say the sun's rotational speed is 28 days, well, that might be a little bit misleading, and here's why. The reason why is because the equator rotates at a faster speed than the mid-latitudes, rotates at a faster speed than the poles. So the average surface rotation of the closest star is about 28 days. But, you know, again, that does 27.27 days. And here's a very interesting view from the Hinode. This is going to show you 5 years of 27.3 days. So check this out. This will be pretty sweet. So that's 5 years. You're almost looking at the same part of the sun there. So that's like, you can see the coronal holes kind of in the same spot and so on. Very interesting. We'll put that on loop and let it play through. Here's the opposite side through that same period. So that's a 5-year period of 1 frame per 27.3 days. You may be able to see the differences in the rotation speeds there. But what's really interesting about that is that it'll show you the features in largely the same spots. So we'll let that play through a second time here for you to get a grip on it. Get a grip, folks. By the way, the sun's not going to kill you. Get a grip on that. If you haven't already got one. So it shows great evolution of the coronal holes, and you can see their migration happening there. And if you look up Carrington rotation on Wiki, you'll be able to find it. Carrington rotation. The orbital periodicity of the closest star. Which makes it time to move on to sunspots. So as we transition to sunspots from coronal holes, again, we do have some sunspots increasing in size and a little bit of complexity increases happening. It's a slight uptick from yesterday. Let's bring up let's bring up yesterday plus today here. So that's the 24th and 25th. We've zoomed in a little bit. We still do have the time and date stamps visible down there. So minor uptick here, some evolution of these sunspots, a little bit of growth in some areas. Lots of sunspots on the Earth-facing portion of the solar disk and lots of filaments. Likelihood of solar flares remains kind of high. These spots have been underperforming. Let's get to energetic particles and solar flares. Proton flux remains flatlined. No relativistic particles there showing up in the past few days. And no major flares. And indeed, the flare profile has shrunk. So interestingly enough, despite increased magnetic complexity and a little bit of growth in sunspots and radio flux, we see the X-ray flux dipping. Don't expect that to hold out. Here's the past 24 hours and GOES RSUVI 94 plus 131 angstroms. That's what we started out the video with. This is the full disk view. Let's step back and orient ourselves, as I'm always interested in what's going on overhead. Lehigh Valley, Pennsylvania, in the U.S. is where we are located. And if you want to bring up your own star chart, the one we've been using is skyandtelescope.org. Just click the Now button once you've entered your zip code, and you'll be able to see where you're located. We've got Saturn, the Sun, Mercury, Jupiter, and Venus having just come over the horizon here over Lehigh Valley, Pennsylvania. Again, skyandtelescope.org doesn't pay us to say this. Maybe we'll get it on the cycling jerseys for next year. But at the moment, That is a free endorsement from the Smash News Network. Least busted name in news. So here is our solar system forecast. This is where things are now. Let's advance this 1 week as the Earth descends into a more and more lonely side of the solar system. Here's where things will be on April 1st, otherwise known as April Fool's Day. And we hope you're not being fooled by fools on YouTube about planets and space weather and things of this nature. Next, we'll look at coronagraphs, as we have had some CMEs in the past 24 hours, so let's take a look at those. So there are yesterday's images. You can see one happening right at the end. Let's take a look at today's images. You'll see the aftermath. And let's take a look at some more detailed images from Stereo A and the Soho Lasco C3. Stereo A here just a few degrees behind Earth. And there are some coronagraphs on the Integrated Space Weather Analysis Center. Stereo A on the left, Soho Lasco C3 on the right, and please, again, pay attention to the date stamps. We say this on the regs, and by the way, that is not an earthly directed coronal mass ejection. Just a minor light show there. As Mercury makes its way out of frame on the Soho Lasco C3. Say bye-bye to Mercury until its next orbit. So no Earth-directed CMEs there in the past 24 hours. Here's a 24-hour video for you. Here's a closer view. That's the GOES R 304 angstroms wavelength. Soho Lasco C2 in red, Soho Lasco C3 coronagraph in blue. Great plasma reorientation happening down here. We'll show you some great imagery of that here in a moment. First, we'll look at filaments. Lots of filaments on the Earth-facing side of the solar disk. There's a huge plume. I mean, if you were looking at this from 90 degrees, there would be a lot of bumpiness in these areas here. There's a lot of material suspended in the corona. They show up in this hydrogen alpha imagery as absorption features. So what's really great about this imagery is that it shows these dark areas. Those are areas that are showing less hydrogen. And it also does show the similar type of filaments as these prominences, where there's a lot more hydrogen than empty space that's not, part of the solar chromosphere. So that's the ground-based solar observatory from Cerro Tololo, Chile. The Gene Simmons filament is still largely intact. I think it might be becoming a prominence over here. This filament to its south could get a name. And we could use some names for some of these filaments as well. So if you want to name filaments, join us on Twitter. We've been naming filaments. Follow the hashtag #NameThatFilament, and hashtag SpaceWX over on Twitter. And by the way, we put up a crazy number of aurorae yesterday and did a live stream. If you missed that yesterday, I don't know if it's been remonetized yet or not. We've also had some vanishing tweets because the software barely functions. So anyway, make sure you join us over there if you're doing things like social media. And I don't know why I have another tab open here. You can also find the link to our free mushroom gummies giveaway over on Twitter. Twitter.com/SmashOmash. All over the internet at SmashOmash. You can find links on the homepage below the video and in other places if you're not aware of where to find us. So here's the past 24 hours in GOES R 304 angstroms. And you see a great plasma reorientation happening down here. I don't think it ejected, as we didn't really see a CME associated with that. But right down here, a massive amount of plasma just kind of making its way down there toward the south solar polar region, the south heliographic pole, and then doesn't seem to eject. So I suspect that is still somewhere. It might be suspended around the edge or something like that. I don't see where it has reestablished a connection. You would have expected that to have ejected. It certainly looked like it would have ejected, but it doesn't. I don't think it did, as we didn't see it on the coronagraph, right? Let us know in the comments what you think about that plasma reorientation. So we do have a CME likely happening here in the, that was a 24-hour video, by the way. This is about 2.5-hour video. We do have a CME likely happening up here in the northeast. It's very unlikely to be earthly directed. Some of that plasma is definitely cascading back down toward the chromosphere, and some of it is probably on its way out in the greater solar system already as we speak. But it looks like most of that has collapsed. So that's where we go from our normal features to our bonus features segment, starting with satellite charging hazards. There's where you've got charging hazards, some minor surface charging taking place here over the Eastern Pacific. Electron flux here on the rise. Perhaps an indication that the coronal hole high-speed stream is ending early. So that could be a pre-ending of coronal hole high-speed stream indicator there. The electron flux a little bit higher here than I would have forecasted. So that could be an indication that this coronal hole high-speed stream is going to be done a little bit earlier than NOAA expected, and the forecast model here calling for lower levels. So I suspect this forecast will be wrong. We're going to see an uptick in the electron flux here instead of a downtick, and perhaps an early end to the coronal hole high-speed stream. Remember, folks, electrons are about 1/1800th the mass of a proton. So they do respond to things a little bit more promptly. They respond to weaker fields than a proton would. Anyway, here is your relativistic electron forecast. Again, that's by NOAA. We're expecting this to be up here tomorrow. Not where that green box is, but let us know what happens tomorrow. There's the 1-year graph to put it in context. We'll show the F flare of the ionosphere, which has been showing some shocking low-frequency anomalies. Oh, wow. Incredible low-frequency anomalies and major shifts there, especially happening over South America and the Eastern Pacific. So huge variations happening there in the ionosphere. You can see it's actually coming back to normal here. So we had extremely low-frequency anomalous ionosphere in yesterday's video to the point where it made it to the thumbnail. Now things are normalizing quite a bit from yesterday. So a bunch of plasma here making its way down into the earthly system. Here's the anomalygram, and you can see massive low-frequency anomalies there, especially in the area north of the equator, I'll say. You can see that simmering down. So that's yesterday, and things getting a lot more normal here. So that's anomaly in megahertz from the 30-day median. And this is the data that you would use to forecast earthquakes if you're using the ionosphere to allegedly forecast earthquakes. Yet another reason why you ought to be watching the channel if you are into space weather, geophysics, and the connections between those two things. We cover space weather from a perspective of cosmology as we are looking out. We're looking from outward in, and earthquake forecasting is looking from inward out. As there's a very different scenario for cosmologists versus geologists and our interest in space weather. So that's part of the reason why we do what we do and don't do certain other things. So the ionosphere here, it's simmering down quite a bit, as we saw an incredible number of low-frequency anomalies. See yesterday's space weather video about that if you missed it. There's the latest image, 1245 universal time ionogram and 1245 universal time anomalygram. We'll also show the total electron content. That's the free electrons between your GPS satellite and your GPS handset, a run of about 12,500 miles. And we've read papers about how this could be used to forecast earthquakes as well. And this would require people who are experts in their local fault lines and their local ionosphere and total electron content environment to know what it normally looks like, especially at this time of year, and then be able to use it in an effective way for what we call predictive value. So we don't just spout nonsense on the channel. We're interested in actual predictive value, not alleged predictive value. And we're seeing actually a very orderly total electron content here. So we do see some major anomalies, which we'll show you here in a minute, but only for North America and the US because, well, the planet's very big and it's too much information to cover in detail. So here is our total electron content anomaly from the 10-day average, and we are seeing some significant anomalies over western Mexico and the eastern Pacific. So those are high electron contents there, and they've been fairly consistent for a couple of days. That looks like a real signal. We'll also turn a little bit here and just show the US. You'll see that same total electron content anomaly there. If that's a forecast for earthquakes in western Mexico and or the eastern Pacific, then so be it. However, we're not fully convinced that this is legit. If it is legit, we've just shown the data. You provide the forecast in the comments if it is a reality as opposed to a fantasy. So here is our high-res imagery. And again, we've got major sunspots here. So these groups haven't been flaring a lot, but there is certainly a lot of capability. So especially those groups, there's a great light bridge over that sunspot. We'll just kind of go around here, showing you the full 4,800 pixel. SDO view, there's a beta class sunspot. There's a bunch of umbra there. That's probably like 100 umbrae. And I don't know, it looks like the sunspot number has been miscounted. I don't know how that could possibly be. But anyway, let's take a look at the magnetic fields. Here's a little tour, a similar tour. So that's a lot of magnetic organization happening in that area. That is extreme magnetic organization, and I mean, it's beta gamma class. Is it beta gamma delta? Parts of that are certainly beta gamma delta class, and trying to view that as multiple sunspots in terms of its physics is just way too much. Overall, that is beta gamma delta class. That one there is alpha class with a light bridge that does show up in the colorized magnetogram. Here's our new sunspot. That's alpha class apparently. And here are some more complex groups in the northern hemisphere. That is beta gamma delta class. So again, these groups have been underperforming. Oh, one more, that one there. That is beta gamma class. Maybe barely beta gamma delta class. There is the full disk view. And as we transition to meteorology, let's take a look at some of the worst places to breathe in the world. So here at the Smash News Network, least busted name in news, we like to cite facts. And so we occasionally give tours of how to use certain software and so forth. So today we're going to look at carbon monoxide. Yeah, carbon monoxide. It's so serious that it's covered in parts per billion as opposed to parts per million. And the highest carbon monoxide contents in the world are 10 times the background levels, as we've got 2,645 parts per billion right there and only 192 parts per billion over there. If you're wondering where it's located, that is that Chile? Chile. It's Chile. Chile. Or something. I have no idea where the national boundaries are there. But there's a pretty bad place to breathe in Central Africa. 2,447 parts per billion. Carbon monoxide. One of the many features of nullschool.net. So here come the meteorology portions of the video. We'll blast through surface winds for the eastern world, jet streams of the eastern world, jet streams of the western world, surface winds of this side of the planet. Strong low continues to loiter off the coast of Newfoundland. Surface winds of the central world, Europe, Africa, and the Middle East looking like this. And these are the jet streams. We've also got clouds and fog over the Americas, so we figured we'd show it to you. Check out the NASA Goes Interactive Weather Satellite Suite if you want to bring out some sweet data like this yourself. What's great about the 3.9 nanometer radiation satellite is that it shows you clouds and fog at nighttime, which is a great way to view the aurora to see if you've got clear skies or if clear skies are coming. Here's our weather.gov map. If your location's lit, head to weather.gov and click your location. We've scrolled down to show you the key, which is about as much as we can do at weather.gov. Here are some forecasts for the U.S., at least the lower 48. That's your GFS 72-hour positive accumulated snow depth change in inches. Heaviest snows are forecasted for northern Wyoming. Here's your GFS 72-hour pressure and precipitation forecast. And some unfortunate things occurred in Mississippi. We forecasted yesterday for the possibility of damaging winds, hail, and possible tornadic activity, and indeed at least 23 killed by tornadoes in Mississippi. So that was your pressure and precipitation forecast based on a GFS model. And let me just press refresh there as it's showing you a bunch of nonsense. Yeah, we had to turn ads on in order for AccuWeather.com's page to be displayed correctly. So yeah, at least 23 killed, decimating Mississippi towns. And I've lost control of my browser. AccuWeather.com has taken control. And we're hoping no noise pollution's been created by this. All right, those are muted. That's good. There is some great ads that we're not going to play. Also, we found another interesting story here while I was browsing. Satellite details reveal sharp turnaround in water levels in California reservoirs. Check it out. If you're worried about California drying out, well, the past few months have made a major change. Here's what's going on in Lake Oroville. It is looking pretty much back to normal, wouldn't you say? It's been a bit on the moist side in California. So here's what's going on in terms of our current precipitation type. This is precipitation type over North America. There is the lower 48. It'll show you rain in blue, snow in white, a mix in yellow, wet snow in green, and freezing rain in pink. Beware the freezing rain. That is not a condition in which to drive. Now, when we were messing with the NASA Goes Lightning Mapper that we show regularly, it defaulted us to the Himawari 8. So we just decided to leave the Himawari 8 up. Oh, no, wait, now we're on the Goes 16. What is going on with that? And it's the Himawari 9. I have no idea what I'm talking about. Anyway, let's take a look at lightning. Here's where current lightning is happening, and we do indeed have some active strikes in the U.S. Next time you hear thunder, perhaps check out lightningmaps.org, powered by blitzachtung.org. It'll even allow you to forecast thunder and look like a horror movie villain, or perhaps Zeus. Zeus, we apologize if you're a Greek viewer who does not realize that Zeus is a wanker. Zeus is a wanker, everybody. I'm a firm believer in this fact. Oh, we had a terrestrial strike here. What's going on? Just northeast of Eglin Air Force Base. Looks like it's moving to the northeast. Couple minor terrestrial strikes there near the U.S. Gulf Coast. Continuing on to our U.S. Doppler radar map. Here's where things are. At least, here's where things are moving vertically in the air column. Things like water droplets and ice crystals. Here's a satellite-based system showing clouds and fog. And here is a water vapor map showing you the breakup and push out of all that moisture. So we've got two separate pulses here, one from the south and one from the southwest, both forcing things up to the northeast. So that should clear out here fairly promptly, although there is some warm air down here creating a bit of a low. You can see some rapid cloud nucleation happening down there as water on the ground becomes water in the air. Keep in mind, when you have very dry air aloft, it does indeed increase the probability of rapid evaporation, so that you can have sudden cloud formation, thunderheads, and things like that. Anyway, here's your recap. U.S. Doppler radar, 3.9 nanometer infrared radiation map. It shows clouds and fog, and there is water vapor. Hopefully that clears things up. That shouldn't be cloudy or foggy. Thanks for tuning in to the Smash News Network, least busted name in news. And may that solar wind be at your back.